Question 2 tells us that we have 20 athletes, and out of the 20, 6 have used performance-enhancing drugs. And then we pick 2 athletes randomly from the group, and let's call our random variable x the number of athletes out of those 2 in our sample who have used the drugs. And we want to create the probability distribution. Now, when we say that we want to write the probability distribution, that means that we just want a table where one column is the values that our random variable takes, and the second column is the probability that x takes that value. So we have 2 athletes in our sample, and x is the number out of those 2 that have used the performance-enhancing drugs. So the possible outcomes, the possible values for x is that 0 out of the 2 have taken the drugs, 1 out of the 2 has taken the drugs, or both of them. So then, to finish our distribution, all we have to do is find those probabilities. And to do that, we're going to make a probability tree. What a probability tree does is we use it to visualize all the possible outcomes in our experiment. So let's take our first athlete. I'll call them athlete 1, or A1 for short. The 2 possible outcomes for athlete 1 is that the athlete took the performance-enhancing drugs, or they did not take any drugs. So we're given that out of the 20 athletes, 6 of them used the performance-enhancing drugs. So the probability that the first athlete took the performance-enhancing drugs is then 6 out of 20. And then the probability that he didn't is just the opposite. 1 minus 6 out of 20, which is 14 out of 20. So that's for athlete 1. Let's do this now for athlete 2. So take my tree and draw the branches corresponding to athlete 2. Alright, so athlete 2 either took the drugs or did not, so I'll write out those outcomes. So let's take a look at this branch. What's the probability that the second athlete took drugs if the first athlete did too? So the first thing I have to note is that, well, I've already chosen one athlete, so I only have 19 left, right? The first athlete took the drugs. Now, given that I know that the first athlete took the drugs, the probability that the second one took drugs must be 5 out of 19, because I've taken the first one out of my sample, out of my group. Now let's suppose athlete 1 took the drug, but the second athlete did not. Again, my denominator will be 19. My numerator will be 14, because the first athlete took the drug, so there are still 14 that did not. All right, let's fill in the probabilities here. So now, suppose that the first athlete did not take the drugs. So then, we still have 6 athletes left who did. And again, that's out of 19 athletes. Now let's look at the outcome where the first athlete did not take drugs and the second athlete didn't either. So then, originally we had 14 athletes who didn't take drugs. We took the athlete 1 out of the sample, so now there's 13 athletes who didn't take drugs out of 19 total. So now we've filled in our tree with all the possible outcomes. Now we can create our tree and fill in our table. I'll move this over here. All right, so what's the probability that no athletes out of the 2 took drugs? So the probability that athlete 1 did not take drugs and athlete 2 did not either. Well, that's 14 out of 20 times 13 out of 19, which is, if you plug that into your calculator, 0.4789. All right, now what's the probability that exactly 1 athlete took the drugs? Well, the probability that only 1 out of our 2 athletes took the drugs is the probability that athlete 1 took the drugs and athlete 2 did not, or the probability that athlete 1 did not and athlete 2 did. So that's equal to the probability that athlete 1 took and athlete 2 did not. Our first term, that's 6 out of 20 times 14 out of 19, plus our second event, that the first athlete did not and the second did. That's 14 out of 20 times 6 out of 19. Add those up, plug that into your calculator, and you should get 0.4422. All right, now our last row in the table. What's the probability that 2 athletes out of our group took drugs? So what's the probability that athlete 1 took the drugs and athlete 1 did not? Athlete 2 did not. That's equal to 6 out of 20 times 14. Oops, that's a mistake. That's not true. What's the probability that the first athlete took the drugs and the second one did? There we go. That's equal to 6 out of 20 times 5 out of 19. There we go. That, if you plug that into your calculator, you should get 0.0789. And that, this table, is your probability distribution.